In a groundbreaking revelation, NASA has announced that Voyager 1 has uncovered something once thought to be impossible. For nearly 50 years, this legendary spacecraft has pushed the boundaries of space exploration, offering humanity an unprecedented look at our solar system and beyond. Now, as the spacecraft approaches the twilight of its mission, it has achieved yet another astonishing feat, one that secures its legacy among the stars forever. So what exactly is this impossible discovery by Voyager 1? How much longer will this trailblazing spacecraft continue its journey? And what final milestones does NASA hope it will achieve before its mission ends? Stay with us as we explore NASA's warning about Voyager 1's incredible impossible finding before it is powered down for good. If any space mission can claim to have left a permanent imprint on the universe, it's Voyager. Launched on September 5, 1977 with the primary goal of studying the outer planets, the Voyager probes far surpassed their original objectives, venturing into unexplored regions of space. Voyager 1's epic journey has delighted NASA and scientists worldwide, delivering a treasure trove of insights about our cosmic surroundings. 5 decades after its historic launch, Voyager remains the longest continuously operating mission ever undertaken by a space agency. It's almost miraculous that this probe is still active, especially considering it was initially expected to function for just 5 years. This longevity reflects the brilliant engineering and innovation that went into building Voyager. Both Voyager 1 and 2 incorporated cutting-edge technology for their era, from propulsion systems to communication equipment. Every component was crafted for durability. NASA based their design on the Mariner spacecraft but introduced several key enhancements. Voyager 1 carried 11 different scientific tools, including instruments like the ultraviolet spectrometer, cosmic ray detectors, magnetometer, cameras, and a powerful high-gain antenna. These devices allowed it to study planets, stars, magnetic fields, radiation belts, and atmospheres. NASA also famously included a golden record aboard the probe, a time capsule meant to communicate humanity's existence to any alien life that might encounter it. Creating Voyager was a team effort that involved brilliant minds like Gary Flandreau. This visionary aerospace engineer not only contributed to the spacecraft's design calculations but also charted its critical flight path. Thanks to his work, Voyager 1 overtook its twin launch 2 weeks earlier and became the most distant human-made object in space. Flandreau's work was key to Voyager's success. In the 1960s, he identified a rare cosmic event, a planetary alignment where outer planets gather on the same side of the Sun, an occurrence that happens only once every few centuries. His calculations showed that such an alignment would happen in the 1980s. Motivated by this discovery, NASA accelerated efforts to complete the spacecraft so it could take advantage of this rare opportunity. The alignment allowed Voyager to gain gravitational boosts, slingshotting from one planet to the next and conserving time and fuel. This ingenious technique, often called the slingshot effect, remains vital for deep space missions today, a tribute to Flandreau's foresight. But the success of this method depended heavily on precise trajectory and timing. NASA's team nailed those calculations. To hedge their bets, they sent 2 probes. Voyager 1 targeted Jupiter and Saturn, while Voyager 2 was sent to Uranus and Neptune. These distant worlds were shrouded in mystery at the time, making them prime targets for exploration. The excitement was palpable when the Voyagers not only completed their flybys but also ventured beyond, uncovering cosmic secrets we never imagined. By 1998, Voyager 1 had overtaken Pioneer 10 as the farthest spacecraft from Earth. By 2006, it had reached 9.3 billion miles, and today, it has journeyed over 15 billion miles away. It's no wonder the scientific community remains fascinated by this mission. Even more remarkable is the fact that Voyager 1 is still in contact with Earth, despite having no repairs in all these decades. How does a probe built half a century ago without ever being serviced remain operational and capable of sending back data? The answer lies in the exceptional technology behind it. Voyager 1's communication system, for example, is still functional thanks to NASA's network of receivers and satellites. It features a 12T antenna and uses the Deep Space Network, a global system of radio antennas, to relay messages across unimaginable distances. This network was designed to detect even faint signals from deep space. Voyager's antenna can adjust its orientation to point toward Earth and can communicate on multiple frequencies. Why did NASA make the communication system so advanced? The agency anticipated that most data from Voyager would arrive as radio signals. These signals, even traveling at light speed, can take up to 2 days to reach Earth due to the vast distances involved. Factors like data transmission rates, interference, and antenna alignment affect how quickly and accurately information is exchanged between Voyager and NASA. That's why signal transmission remains such a crucial part of the mission today. With Voyager's cameras and many instruments powered down to conserve energy, its radio communication system is more vital than ever. Without it, Voyager 1 would be little more than debris drifting through space. Thanks to this powerful system, Voyager still transmits data, some of which has raised serious concerns in recent times. Voyager has been sending back puzzling data that sparked alarm among scientists. The strange signals began in 2022, prompting theories about what might be wrong. Speculation about alien involvement gained traction, with some suggesting the probe had been tampered with, while others thought the odd data could be coded messages from extraterrestrials. These theories weren't far-fetched, given that NASA had prepared for the possibility of alien contact by including the golden record on the probes. But aside from the unusual data, there was no concrete evidence of alien interference. Interest in alien theories spiked when the Allen Telescope Array in California, a facility dedicated to searching for extraterrestrial life, detected peculiar signals from Voyager 1. The array used 20 of its 42 dishes to record about 15 minutes of data. While the ATA team praised the telescope's performance, they shared few details about the nature of the data they captured. NASA, undeterred, continued its investigation until they uncovered the true cause: no aliens, just a technical malfunction. The issue stemmed from the flight data system responsible for gathering and transmitting scientific data. For unknown reasons, it began sending a repetitive sequence of zeros and ones. Even after attempting to reset the system, the problem persisted. Eventually, engineers discovered the fault was linked to the attitude articulation and control system, the system that keeps Voyager's antenna aimed at Earth. A miscommunication had caused telemetry data to be routed to the wrong computer. It turns out the computer responsible for this puzzling turn of events had stopped functioning long ago, and any data received from the AACS was immediately corrupted. This corrupted stream of information ended up on NASA's desk, causing much confusion and puzzlement. All NASA needed to do was send a command to Voyager instructing it to route data through the correct computer. Although this mysterious glitch has been resolved, many questions linger. For instance, why did the probe spontaneously switch its data path? Was it sheer chance, or could an external force have triggered it? Once again, speculation about intelligent life finds its way into the conversation. NASA admits that more questions remain, and the puzzle isn't fully solved. Under normal circumstances, the spacecraft's built-in error detection should have flagged the issue. Yet with no alerts, it appears Voyager the first may have rerouted its data intentionally. If so, who or what was behind this unexpected shift? More puzzling data emerged when Voyager entered interstellar space, a realm that has long captivated the scientific community. Interstellar space is a challenging and largely unexplored area, filled with cosmic matter and energy, making it vastly different from the space within our solar system. It's long been theorized that entering this area could reveal extraordinary findings, including evidence of alien life. The scientific world celebrated when Voyager 1 crossed the heliosphere on August 25, 2012, a monumental moment in space exploration. The heliosphere, which shields our solar system from the harsh radiation of interstellar space, marks the boundary we had long hoped to breach. Upon crossing, Voyager offered unprecedented insights, allowing researchers to better understand this mysterious realm beyond our solar limits. The spacecraft's journey shed light on the complex nature of the heliosheath and interstellar medium. Until that point, these regions were largely theoretical, with many questions about their properties. Thanks to Voyager 1, scientists gained a more concrete understanding, making countless new discoveries that reshaped our knowledge of the universe. Through its exploration, Voyager revealed the dynamics of interstellar space, providing vital data about cosmic ray densities, magnetic fields, and plasma waves. The spacecraft detected high-energy cosmic particles originating from supernova explosions and other cosmic events, opening a new chapter in space physics. Today, Voyager 1 is humanity's only working observatory beyond the heliosphere. Its dwindling power supply reminds us that its days may be numbered. Its strength diminishes by roughly 4 watts per year, and current estimates give it 5 to 10 years of operational life, making every moment and every piece of data a precious gift to science. As the spacecraft ventures closer to the Oort cloud, it enters an area that has long intrigued astronomers. This enormous sphere of icy bodies at the edge of our solar system may hold billions or even trillions of comets, making it a profound frontier for exploration. The scientific community can only hope for more discoveries before the spacecraft goes silent for good. Voyager 1 operates using a unique fuel called hydrazine, a simple yet effective propellant for its thrusters. Meanwhile, its primary energy source is plutonium, which powers the spacecraft's instruments through a radioisotope thermoelectric generator, RTG. These RTGs utilize the heat from decaying isotopes, converting it into electrical energy and allowing the spacecraft to operate in deep space despite harsh conditions. While Voyager 1 has enough hydrazine for another 15 years, its plutonium reserves are expected to deplete within 5 years, making its future increasingly uncertain. Once its energy is exhausted, the probe will drift quietly through space, a relic of humankind's scientific ambition. From its historic flybys of Jupiter and Saturn, which unveiled the planet's rings and moons, to its recent revelations about magnetic fields and cosmic rays, Voyager 1 has reshaped our understanding of the universe. Its discovery of rings around Jupiter, new moons like Thebe and Metis, and its profound insights into Saturn's rings and magnetic fields have become foundational knowledge for space exploration. Similarly, its exploration of Uranus offered breakthroughs about its rings and moons, while its journey beyond Neptune shed light on the Kuiper belt and its countless celestial bodies. Its famous pale blue dot photograph forever altered how we perceive our place in the cosmos. Today, only a handful of its instruments remain operational, including its magnetometers, low-energy charged particle instrument, and plasma measuring equipment. Should these continue to operate for another 5 to 10 years, we might still unlock more mysteries about the nature of interstellar space. Looking ahead, some speculate that in roughly 16,000 years, Voyager 1 may approach Proxima Centauri b, a planet within a star system that has long intrigued the scientific world as a possible candidate for hosting alien life. Theories about this nearby star system have circulated for years, prompting speculation about its potential role as a haven for intelligent life. For now, all we can do is watch, wait, and hope that this remarkable spacecraft can continue its mission a little longer, sending back data from the furthest reaches of space. Even when its journey finally ends, Voyager 1 will remain an extraordinary testament to human ingenuity and exploration. Is this a rare cosmic anomaly, or something altogether different? What might Voyager 1 be hiding?